There, myself Krish Adhikar, very warm welcome to all. And in this we talk about little bit core pillars of the security, and this is the important parts of their system design and high level design. We actually focus on their this is important part to discuss, which because of that we actually focus to their system design. So we need to know like what components is necessary in the security part. Also, because of that, making a reliable and secured system, that's a very important part. And nowadays the people are jumping toward their code first and without understanding the security purpose, the what actually going on, what's not, and logic. So the first today's actually the main purpose for today that we focus on the security, the big pillars of the security. So what we can do, what not can we do. So overall plan for today, the first we discuss CIA, confidentiality, and integrity and availability. So this is the core pillars of the security of any design, and you should to know about this. Okay, so when you're talking about this particular core pillars, confidentiality refer to encryption. How can you encrypt the data and decrypt the data from when data especially transit from one place to another place, and when data in rest and databases. So encryption is important part, so we discuss all about in confidentiality. And integrity refer to something, how can you know that this particular data is accurate and consistent. Okay, so uh, and trustworthy. So that's basic one in integrity refer to. And availability is how can we just available data for the particular user, and that's the important part to discuss. So that's okay. And I think like that's today's we discuss about little bit one by one each of them, and hope so it's the particular video going to very productive if you do so. And okay, so let's start. Let's come to the confidentiality. And in this part, we actually confidentiality refer to something we can hide. How can we hide the particular information at certain limits of the time? And we only give the particular access of the data to original user, which is validated user, not at unauthorized user. So basically confidentiality, we discussed a little bit about plain text, a little bit about inscription, and that's the basic I think like the best way to protect our data from when actually data in a in a rest, and when data actually transport between the different locations and two different systems. So we need to just keep the particular data as a safe and confidential to just protect from the hackers and to stealing the data. So in that particular one, for example, you have lots of idea like lots of idea around it, but hackers actually generally use the lots of technique to just steal the data when actually data transit between two different one. But what happen if this particular one is like confidential, if the one is changed into different text, and the hacker cannot access this particular data because if they require such a key. So let's suppose the best example I give you the best example for understand inscription process. Like now suppose you want to just you want to send some money to your friend. Okay, by I think like post by post. But you think like someone can take and this particular money and they steal the money. Okay, and the way that you can use is like you pack this money in a box with a secret key. Okay, and that the particular key you and your friend only knows about the particular key. And you send this particular key to the particular post office, and post office send to that one. So if anyone get want to access this particular money from there which is under the box, and that they cannot know what the secret key is. Okay, and they can't access this particular one, so they are not they can't access this particular money for them. So in that particular part we actually know that this is the basic one to know that key we need to just we secure the communication between two different. Okay, so that the particular one is like cryptography. So that's the particular one is called cryptography in like ancient times in the like few 18s 90s. The peoples are using cryptography, say this particular one cryptography. Because of that, how can we secure the digital communication? How we know that this particular data is going to right place and validate and authorize user, and unlock only the validated user can access this particular information. So that the particular like logic running behind a scene. So that similar sounds like the inscription. Inscription is like similar. It take a plain text. Okay, now suppose if you want to send a particular information, let's suppose you want to just send some text in WhatsApp. WhatsApp is all about some kinds of data. Okay, in WhatsApp, this particular plain text converted into encrypted this particular plain text encrypted by secret key. Okay, so is like some numbers of the code that you and only original validated user knows about it. Okay, and this plain text are encrypted with a secret key. Okay, this is secret key. Now suppose 1234. This is not a normal number they're using. They use a long numbers of the code. Okay, and they encrypted with their particular secret key, and that's called ciphertext. The encrypted text which actually converted into ciphertext, which are not in readable format. Okay, which is locked by secret key. Okay, that particular text is locked by secret key, so that's called a secret text. And in that part, secret key are decrypted at the validated user. So only validated user can decrypt this particular secret key, ciphertext, and then after they get plain text. Okay, so what kind of information? So what's the promise that we actually doing the end-to-end encrypted network? So they want to say that like our communication between two different ones, so no middle man comes in that place and no one steal data. So it's like look like something, the two person of the two system, let's suppose two system communicating each other by, I think, inscription, that they know the what inscription key is. They also know encrypted key, and they know decrypted key, and they know also encrypted key. They encrypt and they decrypt. Okay, so they know what the secret key is, and they the conversation between going both of them is very but fine. Okay, and what happen if the someone come and access this particular data? If someone want to just access this particular, they get this particular data, but they cannot unlock this particular data because of they don't know what the secret key is, and it's impossible to unlock because secret key is like using very high mathematical algorithm. We the secret key is designed. Okay, and at certain points of the time secret key change in the loop. Okay, so that's the basic scene behind it, and that's all about it. Like that thing happened inside it. And actually when we're talking about inscription are basically two type: symmetric inscription and asymmetric inscription. So symmetric inscription is all about like both uh, systems, in that both system knows about what the secret key is, and they encrypt and decrypt according to it, the data transfer and all this particular one. So inscription is not about only for data communication, leave a different data communication between like digital assets. Okay, inscription is also work when actually data in rest in like specific server in specific databases. This data in encrypted way, so no one can access data, and if they get access, they got without secret key, they not unlock this particular one. Okay, so that's the basic one that we're talking about. So symmetric inscription, but the both parties know about like uh, what the inscription, what is the secret key is. And asymmetric inscription refer to something the first party knows the public. Encrypted key is public, and decrypted key is private. For description, descripting a particular ciphertext, we need to a private key. For encrypted, we need a public key. So it sounds like confusing, but public key refer to the anyone can know, and it is openly released uh, secret key. So anyone encrypt that message. But for description, description, we actually need a secret private key for descripting it. So that's the particular difference between symmetric and asymmetric inscription, and the both are such as different in case, but we can just walk like look toward them. And that's an important part of the inscription. And when we are actually talking about the CIA trade-off, and CIA trade-off is all about combination of confidentiality, integrity, and availability. But CIA is most part of the confidentiality when you're talking about inscription first. Okay, so the main priority that we discuss for confidentiality is inscription, and inscription is very important because of that. We actually dealing with always anyone's dealing with API. So API, we need to choose a right inscription process. So I think if you want to just Mac application, the libraries and framework are actually available here. I don't think so, but library is available here to just encrypt that particular one, that two different vision communication with two layers. So that's all about it. Okay, fine. Let's come to the next part. let's come to the first part, second part, integrity. And in this integrity, we actually focus on this is important because this is also basic big pillar of the security and high level design we especially talk about. Basically, in the security, which in talk about little bit about integrity. Integrity is about accuracy, consistency, and trust. So how can we know this particular data is it transits between two different system? Then the particular data is accurate. Okay, so integrity ensure that the data transferred between two different two different systems are accurate. Okay, so and second one is all about consistency and trust. So uh, the data transfer between the different one without losing any data packet. So I will try to explain you. Let's suppose there's two systems, user A and user B. This both systems are communicating with each other. So we need to integrity ensure that the particular communication between two different one is going to accurate. Accurate refer to something those data that this particular one sent high. Okay, high. They that also receive also high, not at hello. Okay, so accurate data. Okay, they receive high. So they also receive accurate data. Second one is consistency. Consistency refer to suppose hi, I am John. User A send a particular message to the user B as hi, I am John, and that user B get that kind of receive that information. Hi, I am a John. Not there is a no missing gap between any data points, any data packet losses. Hi, it's look like if the particular data mismatch that we can call the data will not consistent. Okay, so integrity ensure that particular thing the data will be accurate transfer between two different communication to different systems, and our data will be consistent in that place with two different systems, and data will look like trust. Okay, so we need to ensure that the particular one trust. For example, why we are talking about trust in integrity, when we talking about trust, because of that user A sent to user B, how can we know that user A sent to the user B, and why the particular person only receive user B, why not user C can receive this particular information? So the controversy here is we are in a dilemma, and for solving this particular dilemma, the one particular possible thing is like digital signature. When user A send email to user B, that actually user A generate a digital signature, and after this digital signature verify with the user B, and it's both communicate each other. Okay, so digital signature is just proof of the particular person who send the particular data to particular user and who receive it. So we need to ensure the trust between two different communications, and integrity is all about accuracy, consistency, and trust. So few common tools which actually use to just do for unlock the potential of the integrity, like hashing, backup, and permission. So hashing is all about when you actually want to just send particular plain text to particular person. A plain text, it converted it encoded into the hash is just as a binary numbers at like 0 1 1 something different. Okay, so converted into hash. Okay, it's like a human can't understand this particular one hash. Okay, so plain text encoded into hash, and after this particular one, this particular decoded into uh, hash. Okay, decode the hash, and that the basic thing running behind the scene. So hashing is a process where we encode into hash, so no one can read the particular one, and when this particular information goes to the particular different system, either original validated system, they can decode this particular hash and they understand what they actually want to say. So encode hash, decode hash, and convert it into plain text for the particular validated user. So that the basic one hashing is. And backup, so backup is important because of that, to ensuring this particular consistency, because if sometime we lost lots of information and corrupted files also. So we need to also keep the backup plan for that particular security purpose. Because of that, we can recover that information as soon as possible. Second one is permission. We are not going to just give permission to any user to access the information. We are restrict user permission and giving a only uh, simple opportunity to access a particular information, not at very high. So that's all about like integrity. Integrity is all about accuracy, consistency, and trust. So this is a way to understand about integrity. See you soon, and let's come to the next part. Hey, let's come to the next part is like availability. In this particular part, we actually discuss about availability. So availability is also a big part of the CIA trade up, and security purpose this is necessary to ensure. Okay, so let's start with that. Availability is all about redundancy, monitoring, and resilience. So redundancy is all about like I try to explain you availability in like three magic words. So redundancy is all about something we are going make a backup plan for any data protection. So now suppose it's all about backup plan. Monitoring refer to monitor user regular. Okay, so I think monitoring is important, and I give a best example for this. You know about like few adult, I don't know, few videos with like toxic videos. I'm not going to just share with AI generated video. So YouTube restrict. Let's suppose YouTube want to register AI. They want to just make a platform where only human creators are available there, no AI creators. So they need to ensure that monitor all the particular regular users to ensure that the particular one is like which is basic. They are not upload AI video. So they were ensure that they remove the AI creators and only keep their human creators also. So that's the basic thing, and that's monitoring refer to. And resilience is about recover from the failure. So how much you recover from the failure. So that's the basic part. So redundancy is a hardware and geographical. So redundancy refer to something make a backup plan. So what we actually do here in that part, actually we focus on their we need to ensure that the particular data, if the data lost, and how can we just recover this data. We need to replicate this data in different nodes and different hardwares. So redundancy is all about backup plan. What the backup plan that you make with the data will be when you actually scale a purchase. So customer data is very important to just you need to backup plan for it. If you don't do so, then I think you list your that lots of thing like lots of loss happen inside the business logic and lots of area. So redundancy is an important part. So there were two types: hardware redundancy and geographical redundancy. So hardware redundancy refer to something you choose lots of hardware there to replicate the particular data in different hardwares. Okay, to ensure that if the particular hardware is corrupted, then other hardware can be access the particular same data from the other hardware, replicated data. So that's all about the hardware data. And geographical is all about across different locations. You replicate this data and just spread the data in different locations. So when you, if the one part is failed, one location are not responding, then other one can respond and give a response, and you find out the data. So that's all about it. And monitoring refer to how can you monitor your data, how can monitor your user at regular basis for understanding more about it, like psychological effect. Okay, so I know what the behaviors of the user. And monitoring is important. Because of that, when you actually focus on the piece purpose of the business logic, the monitoring is the very important part. So Apache Flink and AWS and Google Cloud, normally cloud servers, cloud SAP are also facilitate monitoring tools, but Apache Flink is also one of the best option for this. Okay, so let's come to the resilience. Resilience is like auto scaling, health check, and contained orchestration. Resilience is all about recovering from the failure, how bounce back from the failure. So bounce back from the failure is the only way is auto scaling. So mainly we faced lots of problem in auto scaling, scale. We need to just shift a horizontal to vertical scaling, but it's take a time to do this particular one. But what happen if the particular system is already designed? They auto scale the particular if they on the user when the user grows, when the traffic grows. So that's is the auto scaling. And the second one is the health check. So that's the important, because of regular basis where we need to check health. Because of that, that's ensure that the particular system is alive or not alive. And contain orchestration is all important. Like container orchestration is important because when we actually need to contain, like we need to coordinate each orchestration part, what next, and then orchestration is important. Okay, so that's all about their, you can say, in their availability. And availability is all about redundancy, monitoring, and resilience. So we keep toward the three important one, keeping in mind in availability, how can we just make a backup plan, how can we bounce back from the failure, how can we monitor the user. So that's the important part. So okay, so thanks for watching and see you soon.